In the previous activity to start this chapter, we use these Venn diagrams, these circles, to put the different attribute pieces into groups based on their characteristics. And this introduces us to the idea of sets. So we're going to talk about in this video sets and their elements. So what is a set? What is a set? So a set can be defined as a collection of objects. And they can be anything. They can be numbers, they can be words, they can be letters, they can be ideas, anything. So a set is a collection of objects, and those objects are called elements. So sets are made up of elements. They can be described, so a set can be described a couple different ways. It can be described using words, or something we call set notation. Mathematics is full of that, right? Things can be described in words one way, or we can translate it to a grouping of mathematical symbols, which we often refer to as the notation. And so the notation of a set uses braces that look like this. And inside those braces, we would list the elements of the set. After, comma, one after the other. We'll see what that looks like. So that's set notation. So sets are sometimes defined by a name as well. So let me give you a couple of examples of these. I'm going to say set A. So we're going to name this set set A. That's the capital letter will be the name of the set. Set A, if I describe it in words, is the letters in the word Mississippi. Mississippi. So set A is the letters in the word Mississippi. So that's describing the set in words. If I want to use notation, I say A equals, so set A is equal to, and then I put braces, and then I would look at the word Mississippi, and I see it has these letters, M, I, S, and P. Notice I put them in lowercase, M, I, S, and P. So that's how we write set notation. And notice that none of the elements are repeated within those braces. We only state them once. So here's another one. Let's say set B, let's work with set B, and set B is US states that start with the letter C. So US states that start with the letter C. If we actually want to then list them, write it in set notation, we would say B is equal to, and we would say California, Colorado, and Connecticut. So those are the US states that start with the letter C. So there's the set of those states. Let's do one more, a numerical one. Let's say set T is equal to, or sorry, is, I'm not doing equals yet. Set T is multiples of 10 from 10 to 500. So set T is all the numbers that are multiples of 10 from 10 up to 500. And so we would say T is equal to 10, 20, 30, 40. You're probably wondering if I'm going to list them all. I'm not. When we have large sets like this, you can use what's called an ellipse, which is 3 periods, dot, dot, dot. And what that shows is that you have some pattern that is continued throughout those ellipses, and you can just sort of leave them out, right? We don't have to write everything. It establishes the pattern, it leaves off the ones in the middle, and then it continues. So that's what we would say is set T if we wrote it in set notation. Some elements have no, or some sets have no elements in them. So this is called an empty set. So the empty set is a set with no elements. A set with no elements. So to give you a couple examples of that, one other thing, sometimes it can be referred to as the null set. So if you hear null set, that's the same thing as empty set. So it's a set with no elements. So let's say set D is the states, the United States, the US states that start with the letter E. There are no states that start with the letter E. So we would say set D is equal to, there are 2 different ways we can do it. One way is we make the braces and we just don't put anything in them. Another thing we can do is use this symbol, a 0 with a slash through it. That means the empty set, all right? So that symbol does have a very specific mathematical definition. If you're looking for a numerical one, let's say set F is all whole numbers between 16 and 28 that can be evenly divided by 15. So list all of the numbers, all of the whole numbers that are between 16 and 28, but they can be evenly divided by 15. That means they're a multiple of 15. Well, the numbers that are multiples of 15 would be 15, 30, 45. There are none that are between 16 and 28. So we would say F is the empty set, okay? So just take a pause for a minute and think, can you create, right? The next level of understanding conceptually of something is, can you create it on your own? So just pause and say, could I create a couple examples of empty sets? It could be something to do with words or numbers. So just go ahead and pause and see if you can do that. So maybe you came up with something, maybe you didn't. You could do another US state. You could say a set is the United States presidents that have served for 5 terms. Well, there are none of those. You can say it is the US coins that are worth 17 cents. There are none. So it's really anything that would not have any elements in it. The group of those attribute pieces that we worked with earlier that are pentagons, there were none. Okay, so moving on to a new concept. This is where we start to really introduce a lot more symbols, okay? So we're going to talk about what's called set membership. Set membership. How do we show through some use of symbols that a particular element belongs to a set? Okay. So the symbol that we use is this. It kind of looks like an E in a little ways, but it's sort of curved. When you see that symbol, it means this phrase is an element of. is an element of. Okay, so for one example, if let set O be the set of odd numbers, the set of odd numbers. Then we could take some number, say the number 3, for example. We could say 3 is an element of set O. So that's the number 3. That is set O, right? 3 is an element of set O. We can also denote if a number is not an element of a set. 4 is not an element of set O. So if you put a diagonal slash through that symbol, it says that is not an element of set O. Okay, so we have, again, different notations that we're already starting to see. So this is a new one for you. And then the negation of that is also probably a new one for you. So again, this means is an element of. All right. So one more thing for this particular video. We're going to talk about the idea of what is called the universal set. The universal set. So the universal set will be different based on the problem you are working with, but it is the set that contains or includes, and my little pad is getting a little wonky here, set that includes all elements that are relevant to the problem. So earlier, in fact, let me just scroll for a second. We did a problem, this one right here, where we were looking at, set B is the US states that start with the letter C. All right, so just consider that for a second. Set B is the US states that start with the letter C. So set B was California, Colorado, and Connecticut. But the universal set would have really been all the US states, right? Any state that's relevant to the problem. And so that would be what we would consider the universal set. The universal set is all US states. All US states. We were specifically looking at the ones that started with C. Maybe this one, set A, is the letters in the word Mississippi. So we're talking about letters, part of the English alphabet. So in that case, the universal set would be considered all of the letters in the English alphabet. We were just focused on the ones in the word Mississippi. So last thing then, let's consider, let the universal set be whole numbers less than 20. Okay, whole numbers that are less than 20. So in this problem that we're going to work on, this is going to be our universal set. So we could say that the universal set, if we wrote it in set notation, would be 1, 2, 3, 4, etc. ... 18, 19, right? Does not include 20 because we said it had to be less than 20. Okay, so what I would like you to do then with your, just on your own, is go back and make a Venn diagram again. So we're going to make another Venn diagram. And so you're going to be drawing two circles again on your paper. I pre-printed mine because it's hard to do on this tablet, especially when it's acting up a little bit. That is the worst Venn diagram I've ever seen. I cannot, that is horrible. That is absolutely horrible. Let me do this instead. Goodness gracious. Okay, there we go. Now we have better Venn diagram. That's much more respectable. I couldn't let that go. Okay, so you've drawn your Venn diagram. You've got your two circles. Remember, they're overlapping a little bit. And what we're going to do is we are going to let set A be the even numbers. And we're going to let set B be multiples of 5. Okay? Even numbers, multiples of 5. And I'm going to put A over here, and I'm going to put B over here. And another thing we often do in Venn diagrams is we have the circles, but then we put like a big rectangle around the circles. And earlier when we were doing that with the attributes, that was just the sheet of paper that we had. But usually we'll put a big rectangle around them because everything in that universal set, all the elements of the universal set have to be inside the rectangle. Okay, so every single element must need to be inside the rectangle. The specific arrangements is dependent upon the rules, right? Set A is the even numbers and set B is the multiple of 5. So take a minute and see if you can figure out where to put all of these numbers appropriately. Pause the video, then come back. So I will continue. Again, we just want to make sure that all of the elements are being considered. So we have to do all these numbers 1 through 19, okay? So if we just start with the number 1 and work our way up, we're really asking ourselves, is each number even or is it a multiple of 5? Well, 1 is not either. 2 is even. 3 is neither. 4 is even. 5 is a multiple of 5, but it's not even, so we're going to put it over here. 6 is even. 7 is neither. 8 is even. 9 is neither. Now 10 is even, so it belongs in this circle, but it's also a multiple of 5, so it belongs in this circle. 11, 12, 13, 14, 15 is another multiple of 5, but it's not even. 16, 17, 18, and 19. So there is our arrangement. There's our Venn diagram. Analyze that. Is that what you had? Check it out. All of our even numbers, 2, 4, 6, or 2, 4, 6, 8, 12, 14, 16, 18, and 10 are all in the circle on the left, 5, 10, and 15, all the circle on the right. And then all our odd numbers that were not multiples of 5, 1, 3, 7, 9, 11, 13, 17, 19, those they were in the universal set, but they had to go outside the circles. So again, we've studied now this idea of sets of individual elements, the notation that we use to show that an element is a member of a set, the idea of the universal set, and then starting to develop our strength using Venn diagrams to show those different arrangements and relationships.